Hello students, good morning everyone. So today we are going to discuss the most important and expected questions for NEET. Okay, so in the part 1 we are going to discuss the expected questions from basic concepts of chemistry. So the basic concepts of chemistry that we already discussed in our first video. Now on the basis of the synopsis we given, now we are going to discuss few important expected questions for NEET examination. So if you look into the first question, a mixture of CO and CO2 contains 60% by volume of CO. 60% by volume of CO. 2 liters of this mixture. 2 liters of this mixture is passed over reddish hard charcoal. Then what is the volume of mixture after the reaction? So he is asking what is the final volume of the mixture after the reaction of this mixture with reddish hard charcoal. Here two important points we should remember here. 60% by volume. He has given the volume fraction of CO gas in the mixture. And the next key point is 2 liters of this mixture, that the total volume of the mixture they have considered is 2 liters. Okay. Now first of all, from the 60% volume of the CO, 60%. So volume percentage is 60%. Okay. So the volume fraction will be, so the fraction of volume fraction is equal to 60 by 100. 60%, percent means per 100, that is 60 by 100, that is equal to 0.6. And they given the total volume of the mixture. What is the volume of the mixture? That is 2 liters. In the 2 liters, then what is the individual volumes of both CO and CO2? Let us calculate. So the volume of CO is equal to, why? Because volume fraction only they give it. CO gas volume fraction they give it. So that is why volume of CO is equal to volume fraction into total volume. That is equal to how much? 1.2 liters. So in that 2 liters, 1.2 liters is the volume of CO. Then the remaining volume will be volume of CO2. So the volume of CO2 is equal to 2 minus 1.2, that is equal to 0.8 liters. Now we know the volume of CO and volume of CO2. Now come to the reaction. When this 2 liters of this mixture is passed over reddish hard charcoal. Yes. Now here, what is the reaction of CO gas and CO2 gas with reddish hard charcoal? Let us discuss. If you take CO2 gas will react with the reddish hard, it will not react with, CO2 will react with the reddish hard charcoal and it will use 2 moles of CO gas. 2 moles of CO gas. Whereas CO gas will not react with charcoal. Okay, CO gas will not react with charcoal, whereas CO2 gas only will react with the charcoal and they use what? Carbon monoxide. And in this stoichiometry, if you see 1 mole of CO2 is giving how many moles of CO? 2 moles of CO it is giving. So if the volume of CO2 is 0.8, then how much volume of CO gas will produces? So if 1 mole produces 2 moles, so from this relation we can say then 0.8 liters of CO2 will produces 2 into 0.8, that is equal to 1.6 liters it will produce. So the volume of CO produced by the CO2 is 1.6. So already some amount of CO gas is already present. How much? 1.2. Okay, why? Because CO is not reacting with the carbon, that CO remains as it is. So therefore, after the reaction, total volume of gaseous mixtures is equal to already present, that is 1.2 plus, and the newly produced, that is 1.6, that is equal to 2.8 liters. So in the given options, 2.8 liters, that is third option. Okay, so once again, in the given problem, It's a mixture of CO and CO2 gases. And in that mixture, 60% by volume of CO2 they given. That means volume fraction of CO is 0.6. Next, when 2 liters of this mixture is passed over reddish hot charcoal, okay, then what is the volume of the mixture after the reaction? So now, in this, from the 0.6 volume fraction, the total volume of the CO is equal to 1.2 liters and the volume of the CO2 is equal to 0.8 liters. Whereas coming to the reaction, the CO2 gas alone can react with the charcoal and giving 2 moles of carbon monoxide, whereas carbon monoxide does not react with them. That is why the total volume of the gases mixture will be 1.8, that is unreacted CO gas, plus 1.6 is the total volume of the CO produced. The total volume is 2.8 liters. How many moles of HCl will be present in 100 ml of solution of specific gravity 1.08 containing 20% of HCl by mass? Okay, so here they have given the data, specific gravity they given, and also 20% of HCl by mass, that means weight percentage they given. So percentage weight they given and the specific gravity they given, and asking to find out the number of moles of HCl present in the 100 ml of the given solution. So for that what I am doing is, first of all I am going to calculate molarity of the given solution. Molarity. Once we calculate the molarity is equal to number of moles by volume. So by using that I can easily calculate the number of moles. So first you calculate the molarity of the solution. So what is the formula for the molarity of the solution from the given specific gravity and percentage? So if the percentage, that is weight percentage, that is equal to how much they given? 20%. Weight percentage, and then specific gravity is how much? 1.08. If they given, then what is the formula for the molarity? That is equal to given percentage into specific gravity into 10 by its gram molar mass. That is the formula, direct formula that we already discussed in the concentration terms. Next, molarity is equal, just substitute the values. What is the percentage? 20%, and the specific gravity 1.08, and into 10 by molar mass of the solution. What is the solution? HCl solution. So what is the molar mass of HCl? That 36.5. So that is equal to how much it will come? So that is the, you can 20 into 10.8 means it will be around 21.6. 21.6 into 10 by 36.5, that is a 216 by 36.5. Okay, so if you divide the 216 with the 36.5, you will get the molarity. I am keeping as it is one. We can divide that. Next, now we know the molarity. Now what is the formula for the number of moles? Number of moles is equal to given molarity into volume in milliliters by 1000. Why? Because the volume they given in milliliters. That is why I am taking directly in milliliters formula. So now you substitute the molarity formula here. So that is equal to 216 by 36.5 into 100 by 1000. That is 2 zeros cancel. So 0 cancel, 21. That is equal to 21.6 by 36.5. So if you divide 21 with 36, so it will be approximately how much will come? 7 3s are 7 4s are approximately 3 4, 0.75 nearest. So 0.8 is the nearest value. So the number of moles present in the given solution is 0.8. So once again, from the given data, the given specific gravity and weight percentage. From the given data, first I calculate the molarity based upon molarity is equal to percentage into specific gravity into 10 by gram molar mass. By using that formula, I calculated the molarity. Next, number of moles is equal to given molarity into volume in milliliters by 1000. By using that formula, I calculated the number of moles. Okay. Next, let us move to the next question. Third question. If 10 power 21 molecules are removed from 200 milligrams of CO2, 200 milligrams of CO2, then number of moles of CO2 left, means after we remove the 10 power 21 molecules, what is the remaining number of molecules is asking. So it's based upon the mole concept. So once again, if 10 power 21 molecules are removed from 200 milligrams of CO2, then the number of moles of CO2 left. Okay, so for that what I am doing, first of all, in this 200 milligrams, in the 200 milligrams, how many molecules are left? First you calculate. So from that number of molecules, subtract this 10 power 21 molecules, so that you will get the remaining number of molecules. So, but he is not asking the remaining number of molecules, he is asking remaining number of moles. So, how to calculate the number of moles from the molecules? Given number of molecules by Avogadro number, you will get the remaining number of moles. Okay. Now, for that, first of all, in the 200 milligrams of CO2, so number of molecules, what is the formula? Number of molecules from the given weight. What is the direct formula is that given weight by its gram molar mass into Avogadro number. So this is a formula, direct formula to calculate the number of moles from the given weight. So just substitute given weight. What is the 200 milligrams, not grams. So milligrams means 10 power minus 3 grams. So 200 into 10 power minus 3 means it will be around 0.2 grams. I am directly writing 0.2 grams by, what is the gram molar mass of CO2? As we know, 12 plus 32, 44 into Avogadro number, that is 6 into 10 power 23. So Avogadro number I am rounding is into 6. Okay, now that is the value. So from that we can get 1.2 by 44 into 10 power 23. Okay, so if you if you calculate 1.2 to 0.6 to 22 0.6 22. Next to 0.3 11, 0.3 by 11, 0.3 by 11 into 10 power 23. Now I am taking as 30, that is equal to 30 by 11 into 10 power 21. 30 by 11 means approximately 11 2s are 22, 11 7s are, and 11 2s are, and then 7, 2.727. So finally we are getting 2.727 into 10 power 21 molecules. So the number of molecules present in given 200 milligrams is 2.7 into 10 power 21. Now from that we are going to subtract 10 power 21. So the remaining number of molecules, is equal to 2.72 into 10 power 21 minus 1.0 into 10 power 21. Okay, 10 power 21 I am writing as 1 into 10 power 21. Here 10 power 21 is a common in both. So if you subtract 1 from the 2.7, so remaining will be 1.72 into 10 power 21 molecules are remaining. Once we get the remaining number of molecules, remaining number of moles formula, given number of molecules by Avogadro number. You just divide this value with Avogadro number, we will get the total number of remaining moles. Okay, so it will be approximately 1.72 into 10 power 21 by Avogadro number 6 into 10 power 23. So if you divide, it will be approximately 10 square, 172 by 6, 172 by 6, sorry, 17.2 into 10 power minus 3 will come. 17.2 by 6 means 6 3s are approximately 2.7, 10 power minus 3, 2.7 approximately. So it will be here 2.88 into 10 power minus 3. Approximately enough. Here 10 power minus 3 and this value here 8.8 to 2.88. There was a difference. So nearly it will get 2.88 into 10 power minus 3. Okay, so this is also one of the important model. That is, chlorine is prepared in the laboratory by treating MnO2 with aqueous HCl according to the given equation. They given the equation also, balanced equation. That is, MnO2 reacts with 4 moles of HCl giving 2 moles of water, 1 mole of manganese chloride and chlorine gas. Now, how many grams of HCl reacts with 5 grams of MnO2? So once again, how many grams of HCl reacts with 5 grams of MnO2? Okay, so this is the question. First of all, let us rewrite the equation. What is the equation they given? That is 1 mole of MnO2 reacts with 4 moles of HCl giving 2 moles of H2O and 1 mole of MnCl2 and 1 mole of chlorine gas. This is a stoichiometrically balanced equation. No need to balance. Okay, in this balanced equation, 1 mole of MnO2 reacts with 4 moles of HCl. Okay, so this is a stoichiometric. 1 mole is reacting with 4 moles. If 1 mole is react, then you convert these moles into weights. What is the weight of 1 mole of MnO2? Okay, what is the atomic weight of manganese? 50. So you should remember these are all values, no? Chromium, manganese. Okay, chromium is 53.5. Okay, and manganese is 55. You can consider. And iron is 56. Okay, now manganese we want, so it's nearly 55. So manganese 55 plus oxygen 32. 32 plus 55, 87. 87 grams consumes how many grams of HCl? 4 moles of HCl. What is the weight of 1 mole of HCl? 36.5. That is equal to 4 into 36.5 grams of HCl. Here once again, 87 grams of MnO2 consuming 4 into 36.5 grams of HCl. Then, what is the question here? He is asking how many grams of HCl reacts with 5 grams of MnO2. Okay, if 87 grams reacts with 4 into 36.5 grams, then 5 grams of MnO2 consumes X grams. Just cross multiply. If you cross multiply, then X is equal to 5 into 4 into 36.5 by 87. Okay, that is equal to 20 into 5 4s are 20 into 36.5 by 87. Okay, you can write it as 365 twos are. 365 twos are how much? That is around 730. So that is equal to 730 by 87. Okay, I think it will be nearly 8.4 grams will come. 87 into 8 is 640. Okay, nearly 8.4 grams will come. Okay, so this is equal to 8.4. Okay, so this is once again, according to the stoichiometric equation, 1 mole of MnO2 reacts with 4 moles of HCl. That means 87 grams is reacting with 4 into 36.5 grams of HCl. Then 5 grams of MnO2 will react with how many grams of HCl? That is the question. Just cross multiplying and calculating the X value. Okay, so let us move to the next one. This is based upon the redox reaction, balancing the redox reactions. Okay, see, for the redox reaction, when 1 mole of when permanganate reacts with oxalate in presence of acidic media, we are getting Mn plus 2 and H2O and CO2 gas. Then correct stoichiometric coefficients of permanganate, oxalate and H plus ions are? So this is a question, and already we discussed and I gave you the trick also how to balance the redox reactions if they given like this. So for that I am taking here, first I am taking MnO4 minus plus C2O4 minus 2 giving Mn plus 2 plus CO2. Oxalate always will come out as what? CO2 gas. Okay, now what are the steps? Now first of all, let us calculate the oxidation states. So MnO4 minus, manganese is plus 7 oxidation state, and in oxalate carbon is plus 3 oxidation state. In Mn plus 2 its oxidation state is plus 2, and in CO2 carbon oxidation state is plus 4 oxidation state. Okay, now plus 7 to plus 2, that means it is gaining of decreasing the oxidation state. Decreasing the oxidation state we call it as what? Reduction. Okay, decreasing the oxidation state we call it as reduction. Here MnO4 minus is undergoing reduction, and gaining how many electrons more? Each mole of permanganate is gaining 5 electrons. Next, coming to the oxalate, carbon oxidation state changing from plus 3 to plus 4. Okay, that means increasing the oxidation number. Increasing the oxidation number we call it as oxidation. Okay, and plus 3 to plus 4, each carbon is losing 1 electron. Each carbon is losing 1 electron. Here total how many carbons in each mole? 2 carbons are there. So the total number of electrons lost by one mole is 2 electrons. Okay, always the number of electrons gained by the oxidant should be equal to the number of electrons lost by the reductant. To equate that, what I am doing, you take this many number of permanganates and this many number of oxalates, write the resultant equation, 2MnO4 minus and 5C2O4 minus 2, and accordingly you just balance the other atoms, that is what, 2 moles of Mn plus 2 and 10 moles of CO2. Okay, he is not only asking the coefficients of permanganate and oxalate. In the question he is asking stoichiometric coefficients of permanganate, oxalate and H plus ions also they are asking. That is why we need to balance the hydrogen and oxygen as well. Yes, how to balance the hydrogens and oxygen in a acidic media and a basic media. So here we should know, as we know this is an acidic medium. Why? Because H plus ions are present. Now in case of acidic media, how to balance the oxygens? So the side where the number of oxygens are deficient. So for example, oxygens are deficient in the right hand side. Total how many of oxygens are deficient? Add that many number of H2O. Okay, in case of acidic media. To the side where the hydrogens are deficient, okay, add that side that many number of H plus ions. Okay, H plus ions. This is an acidic medium. Okay, the side, suppose in the right hand side 4 oxygens are deficient, and that side you add that 4 water molecules. Whereas in case of hydrogen balancing, which side the total how many of H plus ions are less, add that many number of H plus ions. Whereas in basic media, same as like acidic media, the side where the oxygens are deficient, add that many number of water molecules, same as it is. Balancing the oxygen is same. Now coming to the hydrogens balancing. Okay, suppose in the left hand side there was a n number of hydrogens are less. Add that many number of H2O in that side. Simultaneously add that the n number of OH minus ions in the opposite side. For example, I just give you an example. For example, in an equation 4 hydrogens are less in the left hand side. Just imagine 4 hydrogens are less in left hand side. So what you should do? You should add 4 water molecules left side, simultaneously 4 OH minus ions in the right side. So that is like this you can balance the hydro. This is only the difference in both acidic media and basic medium. Now this reaction is going on in which media? Acidic media. Why? Because H plus ions they given. So now total how many oxygens in the left side? Let us we count. 2 4s are 8 oxygens and 5 4s are 20. Total 20 plus 8. 28 oxygens are there in left side. Right side only 20 oxygens are there in right side. Now in which side the less number of oxygens? Right side. How many are less? 8 or less. So add 8 H2O in the right hand side. Oxygens are balanced. Now come to the hydrogens. In the hydrogen side H plus ions we need to add. Now count the hydrogens. Is there any hydrogens here? No hydrogens. Here how many of hydrogens? 16 hydrogens are there. That means you just add here 16 H plus so that you will get the balanced equation. Now what are the coefficients of permanganate? 2 and oxalate is a 5 and hydrogen is H plus ions is 16. So the option will be 2, 5, 16. That is the first option. Okay, so like this you can easily answer the questions. Next, let us move to the next question. A mixture of gases contains hydrogen and oxygen gases in the ratio of 1:4. So that is the weight ratio. Weight ratio of hydrogen and oxygen they given, that is equal to 1:4. Then what is the molar ratio of two gases in the mixture? He is asking the molar ratio, means ratio of their moles. By giving the weight ratio, they are asking mole ratio. As we know, the formula for the moles, suppose if they given you the weights, what is the formula for the number of moles? Number of moles is equal to given weight by its gram molar mass. So if you divide that weight ratio with their molecular masses, we get the molar ratio. So I am writing weight ratio, weight of hydrogen to the weight of oxygen. What is the weight ratio they given? That is 1:4. 1/4. Now mole ratio, that is the number of moles of hydrogen by number of moles of oxygen is equal to. So here 1 is the weight of hydrogen. So 1 by, what is the weight of hydrogen? You don't think that atom. Say given molecules H2O2. For our understanding I am writing here. Okay, no problem. You can write H2O2. Again you may be confused. So number of moles of hydrogen to the oxygen is equal to, what is the molecular weight of hydrogen? 2. 1/2 divided by 4/32. 1/2 divided by 4/32. If you simplify 1/2, if you bring this to numerator, it will be reverse. That is 32/4. Then how much it will be? 4/1. That is, what is the molar ratio? 4:1. Sometimes they may ask you volume ratio also. By giving the weight ratio, they may ask you volume ratio. The volume ratios is same as like molar ratio. Why? Because according to Avogadro's law, if equal volumes always contains equal number of moles or equal number of molecules. So if the volume ratio is 4:1, then definitely their moles ratio or molecules ratio remains same. So that is why this kind of question they frequently are asking. Now let us move to the next question, that is density of 12 points. Say here the answer is 4:1. Okay, next one. Density of 12.25% weight by weight H2SO4 solution is 1.056 gram per ml. Then molarity of the solution. So now in the place of specific gravity, now they given what? Density they given. Already this kind of problem already we solved once again. Okay, tell me what are the values they given? What density they given? What is the density they given? That is 1.056 gram per ml. That is the density they given. And also weight ratio, weight percentage, weight by weight percentage is equal to, that is a 12.25%. He's asking what? Molarity. So what is the formula for molarity? Given density, given percentage into density into 10 by gram molar mass of the substance. That is equal to, what is the percentage they given? 12.25 into density how much? 1.056 into 10 by, what is the gram molar of the molar mass of the substance? That is what? H2SO4. That is 98. H2SO4 molecular weight is 98. That is equal to, how much it will be? So 12.25 into 1.096. So if you simplify, so 122.5, 10.56. 12.25 into 10.56 divided by 98. So 10.56 9.5 something will come. 12.25 by 9 point means 3 4s are 3 3s are 4/3. So it will be approximately 0.75 approximately. So 4/3 1.25 approximately. Here the answer nearer to, okay, here 1.32, 1.176, 1.184 all are error values. So we need to solve this accurately. Okay, if you have, once you just go through that, okay, you can get the answer. Okay. We move to the next question. How much volume of water is to be added to dilute 10 ml of 10 normal HCl to make it to decinormal? But I told you this model is very important. This is according to dilution law. Yes, what is the dilution law formula? That is N1V1 is equal to N2V2. N1V1 is equal to N2V2. What are N1V1? Normalities and volumes before the dilution, normality and volume after the dilution. Okay, in the question they given 10 ml of 10 normal HCl. So these are the initial values. So initial normality is how much? 10 normal, and initial volume is 10 ml. Okay, and the final normality to make it to decinormal. What is the meaning of decinormal? That is equal to 0.1 normal, decinormal. So N2 value is 0.1 and V2 we need to calculate. So V2 is equal to 10 into 10 by 0.1. So how much it will be? You bring this 0.1 to numerator, it becomes 10. 10 in 10 cube means 1000 ml. Final volume of the solution is 1000 ml. He is not asking the final volume. He is asking what? Volume of water added. So what is the formula for volume of H2O added? Volume of H2O added is equal to final volume minus initial volume. So what is the final volume we calculated? 1000. So 1000 minus what is the initial volume? 10 ml. That is equal to 990 ml. 990 ml. So 990 ml, third option. Okay. Next, let us move to the next question. The molarity of 1 molar solution. He is asking molarity, small m value. Small m value. The molarity of 1 molar. So molarity they given. Molarity is 1 molar solution of NaCl whose specific gravity is 1.0585 gram per ml. Okay, so how to calculate this? So that means he is asking the relation between molarity and molarity. Relation between them. As we know the formula. Okay, there was a direct relation between the molarity and molarity. Yes, what is the formula? That is molarity is equal to 1000 into molarity by 1000 into density minus molarity into gram molar mass of solute. Gram molar mass of solute. This is a formula, direct formula, direct relation. So once again, molarity is equal to, is asking the molarity only. 1000 into given molarity by 1000 into density minus molarity into gram molar mass of solute. Just to substitute the values, you may get that out. How we do? We know that density. Density is nothing but a specific gravity. You can use specific gravity as density, no problem. Now substitute the values. So 1000 into molarity is 1. Next 1000 into what is the specific gravity they given? Specific gravity is 1.0585. 1.058 I have considered. And molarity 1 into molar mass of solute. What is the solute ma? NaCl. NaCl molecular weight, that is 58.5. 58.5. Why? Because sodium is 23, chlorine is 35.5, total 58.5. That is equal to 1000 divided by. So if you multiply, we get 1058 minus 58.5. So immediately 58. If you subtract 58, so it will be 1000. 1000 by 1000, 1 approximately. So the given molarity is, final molarity of the solution is 1 mole per kg. Okay, so once again, if you know the direct relation, it's very easy to calculate. That is why this is a concentration terms is very in the concentration terms, the formulas are very important. So focus more on the formulas. Not only it comes in basic concepts, in the second year solution concept is also there. There are also concentration terms. 2 times will be repeat. Okay, so this is a molarity relation. Okay, now let's move to the next one. Protons are present in 1.8 grams of NH4 plus ion, ammonium ion. So he is asking the number of protons. He given Na means Avogadro number, 1.2 times of Avogadro number, 1.1 time of Avogadro number, 11 times of Avogadro number. Okay, first of all, in 1.8 grams, how many moles and how many molecules of ammonium ion is present? Let us recalculate. Okay, so first of all, number of moles of ammonium ion is equal to number of moles of ammonium ion is equal to, what is the formula? Given weight by its molecular weight. What is the given weight? 1.8 grams. Okay, and its molecular weight is what? Nitrogen 14 and hydrogens 4 ions are 4. 14 plus 4, 18. That is equal to 0.1. Number of moles of ammonia we got, ammonium ion. Next, number of molecules of ammonium ion. Number of molecules formula, number of moles into Avogadro number. Okay, that is equal to, what is the number of moles? 0.1 into Avogadro number. 0.1 times of Avogadro number. This is the number of molecules, but is not asking the number of molecules. What is the question? How many of protons? Now, in each ammonium ion, how many protons are present? I told you, number of protons is always be equal to its atomic number. Okay, now ammonium ion here, it's it has 1 nitrogen and 4 hydrogens. Okay, and this positive charge or negative charge, that represents the number of electrons, not protons. Protons remains same. So nitrogen has 7 and hydrogen having each one having 1, 4 ones are 4, 7 plus 4, 11. That means each molecule of ammonium ion having 11 protons. So the total number of protons is equal to total number of molecules of ammonium ion into 11. That is equal, what is the total number of molecules? That is 0.1 into Avogadro number into 11. So how much? 0.1 into 11, that means around 1.1. 1.1 times of Avogadro number. So 1.1 times means this is the third option. Okay. Let us move to the next question. The number of molecules in 1 centimeter cube of water is. Okay, he is asking the number of molecules by giving the volume. Okay, what is the relation to the between number of molecules versus volume? We have a formula, direct formula. If you go to the mole concept, then number of molecules is equal to given volume by gram molar volume into Avogadro number. That is the formula. So given volume by gram molar, number of moles into Avogadro number of molecules we get. Okay, now Given volume, what is the volume they given? 1 centimeter cube. Tell me, 1 centimeter cube is equal to how many ml? 1 ml. 1 centimeter cube is nothing but 1 ml. So, given volume is 1. And gram mole volume, 1 mole is always occupies at STP how much of volume? 22,400 ml into Avogadro number. Avogadro number is 6 into 10 power 23. Okay, so if you simplify this, so I am writing this as 6 by 2.24 into 10 power 4 into 10 power 23. 10 power 4 you bring to numerator, minus 4 it becomes, so it will be 10 power 19. 6 by 2.24, so it will be around 2.7. 2.7 into 10 power 19 is the answer. Okay, so 2.7 into 10 power 19. So this number we called as a Loschmidt number. Loschmidt number. What is Loschmidt number? Loschmidt number is nothing but number of molecules present in 1 ml of the solution is called what? Loschmidt number. That is equal to 2.7 into 10 power 19. It's a constant value you can remember. Okay. Next, let us move to the next one. A compound contains 69.5% oxygen and 30.5% nitrogen and its molecular weight is 92. Then the molecular formula of the compound. So first of all, he given percentage ratio 69.5%, 30.5% of nitrogen, and he given molecular weight also 92 is the molecular weight. Then he is asking molecular formula. So it's completely based upon, first of all you should derive the empirical formula. From the empirical formula, empirical weight, you divide the molecular weight with empirical weight, you will get the n value. From that you will get the molecular formula easy. Okay. How? First of all, we know the how to derive the empirical formula given percentages. Okay, we have in a sequence of steps now. Okay, first of all, percentages they given here, nitrogen and oxygen, 2 elements they given, and their percentages. Nitrogen is 30.5 and oxygen is 69.5 percentages. So these are the percentages, and make sure that the total percentage should be 100%, and you can consider these percentages as grams. So the grams is 30.5 grams, 69.5 grams, and thereafter number of moles of atoms you calculate. Number of moles of atoms is equal to given weight by its atomic weights, that is 30.5 by 14 and 69.5 by oxygen atomic weight 16. Okay, thereafter, and what is the value? 30.5 by 14 means it will be around 2.17 will come. Okay, and 69.5 by 16, so it will be around 4.34 something will come. Okay, this is the number of moles of atoms. Thereafter, relative number of moles, relative number of atoms, relative number of atoms. How to calculate? You divide all the number of atoms with the least number. So what is the least value? 2.17 is the least. You divide them with 2.17. 2.17 by 2.17 it will be 1, and 4.34 by 2.17 that is equal to 2. So in the empirical formula is equal to N1O2. Simply we call it as NO2. NO2 is the empirical formula. So the empirical weight is equal to nitrogen 114 is a 14 plus 16 2 is a 32. So total 46 grams empirical weight. Now what is the relation to the molecular weight and empirical weight? As we know, molecular weight is equal to empirical weight into N. Then N is equal to molecular weight by empirical weight. That is equal to molecular weight 92 they given in that problem. 92 by 46 that is equal to 2. N value we got. Once we got the N value 2. So the empirical formula is NO2. So therefore molecular formula is equal to Empirical formula, that is NO2 twice, that is equal to N2O4. So the molecular formula of the given compound is N2O4. So this is also one of the most important model. Okay, now let us move to the next question. So N2O4 is third option. Now let us move to the next one. Which of the following is not correctly matched? So this is according to oxidation states. In the previous video we already discussed what are the rules we need to follow while we are calculating the oxidation states, and what are the exceptional cases also we discussed, a few exceptional cases. Now let us move in detail. In first option, chromium pentoxide, CrO5. The oxidation state of chromium is plus 10, they mention. Is chromium oxidation state is plus 10 in chromium pentoxide? No. In chromium pentoxide, the chromium pentoxide structure is butterfly structure. Out of 10 oxygens, 4 oxygens, suppose if you take the chromium, so double bond O, so like this structure, so total O1, O2, O3, O4, 4 oxygens are in peroxy linkage. Remaining oxygen is only oxide form. So because of the presence of that, X plus 1 into minus 2, because this is an oxide form, and remaining 4 are in minus 1 oxidation state. So oxidation state of chromium in chromium pentoxide is plus 6, not plus 10. So the first option was wrong. Next, move to the next one. Fe3O4. Oxidation state of iron is 8/3. Oxidation state of iron is 8/3. Okay, in Fe3O4, actually Fe3O4 is a mixture of, it's present in the form of FeO and Fe2O3. Fe3O4 is a mixture of FeO and Fe2O3. So in FeO, what is oxidation state of iron? Plus 2. In Fe2O3, each iron oxidation state is plus 3. That means out of 3 irons, 1 iron atom is in plus 2 state and 2 iron atoms are plus 3 state. But make sure that Fe3O4 is always be exist as this ionized form only. In this form only it will be exist. So they may ask you, what are the 3 individual oxidation states of 3 iron atoms? They may ask you. That is 2-3-3 or 3-3-2, 3-2-3, whatever it may be. Okay, but the average oxidation state, if you take the average oxidation state, how to calculate the sum of oxidation states of all divided by the total number? So 1 into 2 plus 2 into 3 by 3. So 8/3. But here he has not mentioned the average. Suppose if they mention the average oxidation state of iron is 8/3, then it will be correct option. But he has not mentioned, so that is why this is also wrong. Next, come to the third one. Sodium mercury means sodium amalgam. The oxidation state of sodium is plus 1. But as we know, in all amalgams, the oxidation state of the metal is always be 0. But he given plus 1. So this is also wrong option. So in the given question, all the given 3 statements are wrong. So fourth option is the right option. All are correct. All of them. Next one. The correct set of oxidation state of nitrogen and ammonium nitrite. Even this is also very important one. Ammonium nitrite. Okay, if you take the ammonium nitrite, this is also one exceptional case. No, you should remember as like chromium pentoxide and carbon suboxides like that. Okay, now in ammonium nitrite, NH4NO2, ammonium nitrite, it will splits into NH4 plus ion and NO2 minus ion. So what are the individual oxidation states of 2 nitrogens? In ammonium ion, the oxidation state of nitrogen is how much more? Plus 3 it will be. In NO2 minus oxidation state is minus 3 it will be. So what are the individual oxidation states of 2 nitrogens in ammonium nitrate? That is a plus 3 and minus 3. Okay, plus 3 and minus 3. Why? Because ammonium nitrate is a combination of ammonium ion and nitrate ion. In ammonium ion, oxidation state of nitrogen is plus 3. In nitrite ion, oxidation state is minus 3. So the option is what? Plus 3 and minus 3. So that is what? Fourth option. They may give you plus 3 minus 3 or minus 3 plus 3, whatever it may be, no problem. Next, move to the next one. The volume occupied by 4.4 grams of CO2 at STP. So he given weight and he is asking the volume. It's completely based on mole concept. Okay, what is the formula for the volume? Volume of gas occupied by the given weight is equal to, volume is equal to given weight by its gram molar mass into gram molar volume. Okay, GM, that is equal to, what is the given weight? How much weight? 4.4 grams. And what is the gram molar mass of 44 into gram molar mass is 22.4 liters at STP. 4.4 times 44. So we'll get 2.24 liters. Very simple question, but this mole concept, if you know the formula, very easy. If you don't know the formula, I feel very difficulty. So like this, few model question and expected questions here we discuss. Okay, so okay, thank you.